This is Dr. Y.S. Rao. So this is the last concluding session of the QU robot. We will discuss about some applications, some case studies. In the previous session, I asked you to create your own project, think of it. Accordingly, first write a algorithm as I am briefing right now and convert your algorithm into a program. So there are already existing case studies are there. 13 case studies are there, starting with burglar alarm to PC controlled QE robot. I will try to convert first the program into a problem statement and then will demonstrate how the case studies are implemented. On similar guidelines, you can also think of writing the algorithm first, then create the program and verify as per your definition the program is working or not. Right. So the first problem statement is burglar alarm. That means if any theft or any unknown person has entered to so and so area, we would like to start buzzing the alarm. That is a concept. Particularly in agriculture fields also, we have this kind of a problem, like animals and so on. So let's see what we are using. What is the problem statement is. Let us use total 4 sensors. One is LDR, light dependent resistor, which will detect the ambient light. Then we have 3 infrared sensors on the front side of the QE robot. Front left, front right, front center. So write a program to detect what is the intensity of the light, and if the light intensity is less than 60, let's say some unit of 60, then the alarm means in our case buzzer should start buzzing. That is one condition. Or if the front left infrared sensor detect any obstacle, even then the same buzzer should start buzzing. Or if the front right infrared sensor obstacle is detected, then even then the buzzer should buzzing. Or if the front center infrared sensor obstacle is detected, even then the buzzer should be buzzing. So that means it is a OR condition. If any one of these 4 sensors have detected the the value, then the buzzer should be activated. Otherwise, if none of the 4 conditions are satisfied, keep on verifying if any one of the condition is satisfied or not. That means that your program has to be in the infinite loop. However, within the infinite loop, there is another infinite loop where if any one of the condition is satisfied, then the buzzer should be infinitely, should keep on toggling at every 50 milliseconds. So you should create 2 infinite loops, means a loop within the loop. One loop is to verify 4 conditions. Second loop is if any one of the sensor has detected the condition, then again it should enter into infinite loop with a buzzer toggle with every 50 milliseconds. Let me brief you the same thing with the help of the program. So the first program, right, if you remember, in the application folders, the program number 1. In the program number 1, what we have asked is, if you see carefully the program, there are 2 infinite loops. In the first infinite loop, right, we have used the conditional statement, if conditional statement. But interestingly, this conditional statement is verifying, right, how many conditions. We have asked for 4 conditions, right? You can see if you select this condition in the attributes, we have the conditions are 4 conditions. Or if you want to modify this, click on that value. You can see there are conditions, you can OR conditions, AND condition, delete, right? You can do all that, right, editing these operators, values, right? So you have a choice of choosing. You can also, right, you also should modify it, not necessarily you should as it is accept it. But the beauty of the program is you are verifying multiple operators, logical operators and mathematical operators, and the values. For example, for an infrared sensor, the value is only 0 or 1. But for a LDR, the value could be anywhere from 0 to 255. So that's the beauty of the program, where in if condition, where you are verifying 4 conditions in if, right? If any one of these condition is satisfied, then what are you want to do? Again, if the condition is satisfied, then whatever is mentioned in the loop, that is, now again, what is this kind of a loop? Infinite loop. The infinite loop means loop within the loop. So total 3 loops we have used. First is unconditional loop, second is conditional loop, third is again unconditional loop. In the unconditional loop, if it enters, that means if any one of these 4 conditions are any one of the, please understand, because we have used OR operator. If LDR value is less than 40, or if the LDR is left than, if the front left infrared sensor is detected, or if the front right infrared sensor is detected, or if front center infrared detector is detected. If any one of them condition is satisfied, then it will enter into the loop where we are saying buzzer should be toggle and every 50 milliseconds in the infinite loop. So it will never ever will come out of the loop if any one of the condition is satisfied. That's what is the as per our program. Let's load the program. Now program is loaded. Now you see nothing is happening on the board because no obstacle is of either left or right or center, or the LDR is not covered because the intensity, the light is falling on the LDR. Now I will show you all 4 conditions one after another. First, let me close the LDR. So where is the LDR? This is the LDR. Now I have closed the LDR. Now you see the buzzer is continuously buzzing. Even if I remove my finger from the LDR, it is still in the infinite loop because that's what we want, right? Once the condition is satisfied, enter into infinite loop. Now I want to test the remaining 3 conditions. For that, you don't need to load the program, just press the reset button so that the program will be executed again. So now I have pressed the reset button, I will release it. Again, the program is in the initial state. That means waiting for the condition to be satisfied. This time I will use the right side, front right side sensor. I will put a obstacle here. Okay, now see, I have put a obstacle here. The buzzer is buzzing because it has entered into the infinite loop. Again, I will press the reset button. This time, let me verify the center one. See, now center infrared detector is detected. The buzzer is buzzing. Or, because 3 R's, now finally right side. Okay, so the same thing is happening. That's the beauty of the conditional statements, where you can have n number of conditional statements in the program, and once the condition is satisfied, then you decide what operation to be performed. I hope this is a useful program, useful project to understand, to use the multiple loops. First of all, it's not one loop. We have used 3 loops, 2 unconditional loops, 1 conditional loop. And second, the learning in this project is we have verified in conditional loop 4 conditions. Sorry, there is a mistake here, not less than 60, it is less than 40 in the program. So let's say less than 40. So of course you should modify, not necessarily you should use the same value, or you can also have multiple conditions. You can also use AND operation instead of OR operation, or you can use greater than value, instead of less than value or equal to value and so on. Means a specific value only if you get, then only LDR should be on and so on. That's the beauty of the conditional statements as well as the sensors. So two types of sensors we have used. Infrared sensor only will give you two values, either high or low, means binary. However, LDR sensor will give you a range of analog signal 0 to 255, right? The amplitude is continuously changing, but we are looking for a specific value. Then if that specific value reaches, then we want to switch on a buzzer. That's the beauty of the burglar alarm, where we have learned multiple sensors, multiple conditions, multiple loops. In the next session, we will. All right, so the second problem statement case study we would like to implement is sunrise alarm. Sunrise alarm means, like, say, for example, daytime, right? Early in the morning. If the sun rises, the intensity ambient light increases, then probably you want to switch off your lights, fans, or whatever. Like it's like street lights, automatically you want to switch it off, or maybe you want to start your day-to-day activities. So what we want to do is we want to differentiate that the intensity, if it is bright, then some action should takes place. Means exactly opposite to the previous example. In the previous project, we are looking for a dark value, right? Now intensity, this time we are looking for a bright. There is a correction here. Intensity is greater than, let's say, 160. If the condition is satisfied, then buzzer should be toggle every 50 milliseconds. Otherwise, be in the loop. So here also we have conditional loops. Only thing is only one condition we are looking for, that is the LDR with a value of 160. Right. Let's look at the program. So the program in this case, if you remember our application folder, sunrise alarm. So the program is again three loops, same structure. Only thing is, if condition, we are verifying only LDR value. That too, this time the operator, if you see the operator, we are using only one variable, one operator, and no logical operators, only mathematical operators. Means we are not using multiple conditions, so we are not using any logical operators. And then the value which we are looking for is above, because it is greater than, above 160. So if it is above 160, then this will enter into infinite loop and the buzzer will be buzzing infinitely at every 50 milliseconds. So let's program it. I have done the programming, and particularly for this program, I have switched off all the lights. You can see I have switched off the lights. The reason is now it is in the dark, the program is loaded, but then the buzzer is not buzzing. Now I will switch on the light. Let's see, it will detect and the buzzer will start buzzing or not. Now I have switched on the light. Now you can hear the sound. It is continuously in the infinite loop. If you want to verify, you can see I will press the reset button. Buzzer has stopped. If I remove the button, it will buzz because light is still on. I remove the button. Now it is continuously buzzing. Opposite case, let us verify. I have pressed the reset button and I will switch off the light. Either you switch off the light or cover the LDR with some object. Okay. Either way is okay. So, like for example, this fellow, you have to completely press reset button, completely, now see, I have closed. If I remove the hand, it is buzzing. So either way is okay, either cover it or switch off the lights, make it the dark condition. So that's what we have verified in the program, opposite to the previous case where we are looking for LDR with a greater than 160 as good as the full sunrise has happened and some activity we want to do it. All right. So let us discuss about the third case study about the doorbell using LDR. So if you look at the problem statement, it's about uh, like say again we are using LDR, light intensity detection, and we are looking for a value less than 50. If it is less than 50, the buzzer should toggle for 1 second. It should beep for 1 second and stop. So if the condition is satisfied from the light intensity LDR, then buzzer should toggle for 1 second and stop, and it should come out of the loop. And it should keep on verifying again if the value is less than 50 from the LDR or not. So it's not in the infinite loop. Here it is looking for a condition. If the condition is satisfied, buzzer will be on for 1 second. Again it will come out of the loop to verify the condition. That's what is the expected program. Let's see the program. So as per the program flow, if you write a program or analyze the program, what you can see is, first let us create an infinite loop. In the infinite loop, we have used a conditional statement where we are verifying whether the LDR value is less than 50. If that satisfies, the buzzer is on for 1 second, is off, and this condition is terminated because the loop is executed, and once again it goes back and to see whether the buzzer is still whether the LDR value is still less than 50 or not. Let's verify the program. So program is loaded. All right. Now you can see, you can hear the buzzer sound. If I close the LDR, the buzzer is on. Now if I remove the LDR, again the value is more than 50, so the buzzer is not on. Again I will close this, the buzzer is on. So this is just a conditional statement, and it will be on for 1 second and again off, and look for again the condition to be satisfied. The next problem statement, let's define this way. Initialize the LCD and display on LCD only when if switch 1 is pressed, saying that start. So you should display switch 1 press and start with a delay of 100 milliseconds. And if, means you should use a conditional statement, if the switch 1 is pressed, then again on the display, LCD display avoiding obstacles. Then move the forward motor with a speed of 7. That's all. After that, enter into infinite while loop and verify 3 sensors which are there on the front side, front center, front left, front right. If front center sensor detects any obstacle, then motor move forward with a speed of 10. wait for 500 milliseconds, motor turn left with a speed of 10, wait for 200 milliseconds. So you should, if the front center sensor is detected, move forward motor should be on for 500 milliseconds, and after that turn left motor with a speed of 10 for 200 milliseconds. Instead of that, if front left sensor obstacle is detected, then left motor forward speed should be 10 and right motor should be stopped with 0 speed and wait for 200 milliseconds. Instead of that, else if front right sensor detects any obstacle, then the right motor forward should be on with a speed of 10 and the left motor should be stopped with a 0 speed and wait for 200 milliseconds. If none of the if else conditions are satisfied, then move the forward motor with a speed of 7. This should be, as I said, in the infinite loop. That means you should go back to the statement number 4. Let us look at the program, how it looks like. So you should look for obstacle avoider. Yeah, sorry, there is a correction in the video. We should say obstacle avoider, right? And then first what we want to do, initialize the LCD, and in the while condition, right, means this entire program while condition should start only if switch number 1 is pressed, otherwise do nothing. So that means here when you say after initializing the LCD, right, press W1 to start, right, your display it with a delay of 100 milliseconds. Okay, so it will enter into the while condition if this is satisfied. So what it will display, press SW1 and start. So it should display press SW1, right, and start on the LCD. Right, so wait for 20 milliseconds, and since this condition is satisfied, if the switch is pressed, it will come out of the loop. After that, it should display avoiding obstacles. So on your LCD, it should display in one line, you display avoiding, and in the second line, you display obstacles. Okay. Right. So then motor move forward with a speed of 7 as per the program. While one infinite loop here. So we have two conditional statements here. First is while is conditional, but however here you have while infinite, right? So we are using infinite loop. right? So this is infinite loop. Then we are using if conditional statements as per the program to verify whether front center, front left, front right, which sensor has detected the obstacle. If any one of the condition is satisfied, then in that loop, whatever is mentioned, like move forward, motor with a speed of 10, wait for 500 milliseconds, turn left, speed motor with a 10, wait for 200 milliseconds, and terminate. Else, if front left sensor has detected the obstacle, this will happen. Else, if front right has detected the obstacle, this will happen. Else, the move forward motor should be a speed of 7 and it will go back because you said end while, but end while means here it is a end one, it's a infinite loop. So it will keep on sensing out of these three conditions which condition is satisfied. So let's program. Now program is loaded. Let's see the results. Right, so nothing is happening though I didn't connect any motor, but let's see how the sensors responds. Right, so the system is not starting. Let me mount the LCD. So the message on the LCD as displayed, stating that press SW1 to start. So it is continuously in the loop. Now if I press the first switch, okay, now it is displaying avoid obstacle on the LCD. So now it has entered the conditional loop, if loop. Now if I, now you can see this is your various sensors, okay. If you connect the motors accordingly, a specific motor will be on as and when a specific obstacle, right, is detected. So move forward, move left, move right will takes place. So you can verify as per your logic, the logic which you have written, right, is working or not. All right, so this is your fourth example program on obstacle avoider. The next problem statement is wall hugger. In this problem statement, we are using two sensors and the motors, including LCD. The problem as follows. First, initialize the LCD and display, saying that in first line press SW1, in the second line says start. These two text messages you displayed. Then enter into while loop with a condition looking for switch 1 to press. If the switch is pressed, wait for around 20 milliseconds and go to next step. That means unless the switch is pressed, the next instruction won't be executed. It is continuously waiting for the switch to be pressed. All right. So that completes the while condition. And then on LCD display, display this in first line following right and second lines walls. So that's because it is your robot is looking for the wall, is following the walls. So that's why in the first line display following right and the second line display walls. Wait for 1 second delay and then the motor move forward with a speed of 7. So let's move slightly the motor with a forward direction, both the motors with a speed of 7. Then enter into while loop, but this time unconditional while loop, infinite loop. and then verify the following conditions with if condition. So if front center sensor is 1 or else if front sensor right is 1. For example, if front sensor is 1, then motor should be turned left with a speed of 10, buzzer should be on and wait for 200 milliseconds, buzzer should be off. So what we are trying to do is, since the front center, right, the middle one center is detected, then the vehicle we would like to turn it left side with a speed of 10 and buzzer should be on for 200 milliseconds and switch off the buzzer. Else if front right, the right side sensor is detected, move the motor forward with a speed of 10 and left forward with a speed of 5. So we are turning and the buzzer should be on for 200 milliseconds and buzzer should be off after that. If none of the conditions are satisfied, simply left motor forward with a speed of 10, right motor forward with a speed of 5 and go back to the step number 5. Means again look for the sensors. Which sensor is detected, either front sensor or the front, either front center sensor or front right sensor, and these step number 5, 6, 7, 8 should be repeated again and again. Alright, so this is the program. Let's see the program structure. Example number 5, you can say project number 5, wall hugger. Alright, so as discussed here, to begin with, first initialize the LCD, saying that in the first line display press SW1 and again use the LCD to display in the second line 0, 1 to say start. After that, use conditional while statement, because unless the start button, you can say, for example, switch 1 is pressed, it's in the loop. Once the switch is pressed, it will delay for some time, and since the condition is satisfied, it will come out of the loop. Then the next instruction is again LCD, this time following right. So it will try to move the vehicle right side. That's why we are displaying the message, say following right side. And in the second line, display walls. Wait for 1 second delay. Move the forward motor, right? So with a speed of 7. Now it has started moving the vehicle in the forward direction. Let's enter into infinite loop and then verify the two conditions. One is front center, other is front right. That is about the infrared sensors, the front side infrared sensors. If the front center infrared sensor detects any obstacle, right, if this condition is satisfied, earlier it is moving forward, but since it has come across the front center one, right, then so since center some obstacle is there, then it is saying that okay, now turn left side, and then buzzer should be on. After some delay, buzzer should be off. So now the vehicle has turned and started moving towards the left side. Again we are verifying a conditional statement, front right. By any chance, for example, instead of this front center, right, if a right sensor has detected, then the right motor forward speed, with the speed the motor should be on, and the left motor forward speed should be 5, right. So one motor is forward direction, right motor with a speed of 10, left motor forward speed of 5, right. That means as if you are applying a brakes to the left motor. So that means it will tilt. So then buzzer should be on and with a delay, and buzzer should be off, right? So else means if both the conditions are not satisfied, that means both the sensors are not detected, that means no obstacle is there that side. either on the front center or front right, then left motor forward should be 10 and right motor forward should be 5 and terminate the end statement. But again go back to the while loop. So it will be repeatedly verifying these three two conditions again and again, because while one, what we said, is a infinite loop. All right, so this is what we want, a wall hugger program where it is hugging the wall. If uh, if I want to demonstrate how this actually works, let's see. I mean, earlier we said, let's say, burglar alarm, how it was working. This we have demonstrated. Then doorbell. If we close the LDR, you can see the buzzer is on. Obstacle avoider, the previous program. The three sensors it is continuously checking. The front center, front left, front right. Accordingly, the motors, it is either going forward or changing the direction based on the sensors detection. All right. So similarly, now we said about the wall hugger. Yeah, let's see sunrise alarm also. Again based on the LDR. However, you can see right now it's in the dark. As soon as you throw some light, the buzzer start buzzing. Now about the wall hugger. This time we are using only two sensors. It is just following the wall. Always the tilt is towards the left side. All right. So let's demonstrate the same thing. The board is connected, program is compiled and downloaded, and if you see the board now on LCD, press SW1 to start. Message is displayed. Now it is waiting. It won't go to the next step unless you press the SW1. So if I press the SW1 button, now you can see on the LCD following right wall message is displayed. Now it is looking for that sensor to be detected. Now you can see that buzzer right in the program we said front center, front right, and naturally the motors also will be on accordingly. This sensor we didn't use, right? This side, what we have used is center and right, not this one. All right, so if you mount the motors here, accordingly the motors will start rotating as per the instructions which we have mentioned in the program. So with this, we have completed 5 examples and the 5 projects rather. You should verify it physically, or you also should modify it with some your own innovative ideas which you would like to implement. All right.